Hello, so in today's class we will look at the equation of tangent and normal to the ellipse and result on that. So let us look at the equation of the ellipse. So consider the ellipse with the equation x square by a square plus y square by b square is equal to 1. Then the equation of the tangent at x1 y1 is given by, so we need to replace x square by x1, so we will get x1 by a square, then y square is replaced by y1, so we will get y1 by b square equal to 1. Okay, or in the form y equal to mx plus c, so we can rewrite it as y equal to minus b square by a square x1 by y1 into x plus b square by y1. So this is of the form y equal to mx plus c. So this is the slope. Now once we have this, we can find the equation of the normal. So therefore, equation of normal at the point x1 y1 is, so we'll have y minus y1 equal to, now 1 by slope of the tangent minus 1 by slope of the tangent will come minus 1 by m varum. So that will be a square y1 by b square x1 into x minus x1. So that is going to be the equation of the normal, or we can rewrite it in the form x minus x1 by x1 by a square equal to y minus y1. Just rearrange it, so we can write in this form y1 by b square. So that is the equation of tangent and normal to the ellipse. Now let us look at a result regarding the normals of the ellipse. So we have seen a result for parabola. So for parabola, we have seen that three normals can be drawn to the parabola from a given point, and sum of the ordinates of the feet of the normal is 0. So here we look at another result in the case of ellipse. So let us solve it as a problem. So show that four normals can be drawn to an ellipse to a given point, and the feet of the normals lie on a rectangular hyperbola. So we need to show that four normals can be drawn to an ellipse through a given point. So if you are given a point, then from that point you can draw four normals to the ellipse, and we need to show that the feet of the normals will lie on the hyperbola. So let us first consider a given point, and let us look at the equation of the normal. So we need to show that four normals can be drawn to an ellipse through a given point. So the equation of normal to the ellipse is, we will use this equation. So the equation of normal to the ellipse is, so we have x minus x1 by x1 by a square plus y minus y1 by y1 by b square. So equal to y minus y1 by y1 by b square. So let me call it as equation 1. Now let hk be the given point and let the normal pass through the point hk, and let the normal one pass through the point hk. Now since hk passes through the normal, it will satisfy the equation 1. So therefore hk satisfies 1. So that implies h minus x1 by x1 by a square plus k minus y1 by y1 by b square is equal to now let me, so both are equal, let me take it equal to some lambda. So you have h minus x1 by x1 by a square equal to lambda. So let me divide this by h. Okay, can write it as h by x1 by a square minus so this will become x1 by a square equal to lambda. So that is h by x1 by a square will be equal to lambda plus, so this will become a square. x1 cancel out, so 1 by a square that will go to the numerator, so we will get a square. So therefore h by lambda plus a square will be equal to x1 by a square. So that implies h by, okay, നമുക്ക് കിട്ടിയതാണ് h by lambda plus a square equal to x1 by a square. So let me take 1a to here. So we will get x1 by a equal to ha by lambda plus a square. And similarly y യുടെ equation എന്ന്, so we have k minus y1, so we have k minus y1 by y1 by b square equal to lambda, so that will give y1 by b equal to kb by lambda plus b square. Now since x1 y1 is a point on the ellipse, so therefore it will satisfy the equation of the ellipse. So x1 square by a square plus y1 square by b square is equal to 1. From these two expressions we have got the value of x1 by a and y1 by b. So that implies h square a square by lambda plus a square the whole square will be equal, okay, plus k square b square by lambda plus b square whole square will be equal to 1. Now we can see that this equation is a 4th degree equation. So here നമ്മൾ ക്രോസ് മൾട്ടിപ്ലൈ ചെയ്ത് കഴിയുമ്പോൾ നമുക്ക് ഡിനോമിനേറ്ററിൽ ഇവിടെ ലാംഡ സ്ക്വയർ ആണ് പവർ, ഇവിടെ ലാംഡ സ്ക്വയർ ആണ് പവർ. സോ വെൻ യു ടേക്ക് ദ കോമൺ ഡിനോമിനേറ്റർ യു വിൽ ഗെറ്റ് ലാംഡ plus a square whole square into lambda plus b square whole square. So that will go to the right side. So we are going to get a fourth degree equation. So that is a biquadratic equation, or it's a fourth degree equation. Okay. So therefore it is a biquadratic equation in lambda, and therefore we get 4 values of lambda. Now these 4 values of lambda will correspond to 4 points of the ellipse, and these normal and the normals at these points will pass through the given point. So these 4 values correspond to 4 points on the ellipse, and the normals at these points pass through the given point HK. So we have got 4 points on the ellipse such that it passes through the given point H. And again we have also we have a square plus lambda equal to a square h by x1, അതുപോലെ b square plus lambda is equal to b square k by y. Now subtracting these two equations, so we are going to get a square minus b square equal to a square h by x1 minus b square k by y1. Now the point x1 y1 is the foot of the normal. So the point x1 y1 is the foot of the normal, and therefore the locus of the feet of the normals is obtained by replacing x1 y1 by xy. So hence the locus of the feet of the normals is a square minus b square equal to a square h by x minus b square k by y, or it can be put in the form xy into a square minus b square equal to a square h y minus b square k x. Now this will be the equation of a rectangular hyperbola, which is equation of a rectangular hyperbola. So we will get the required result. So we have shown two things. So that is 4 normals can be drawn to an ellipse through a given point. So we have taken the point HK, and from the point HK, so we have 4 roots to this equation. So 4 normals can be drawn to the ellipse through a given point HK, and the point HK that will give us so the feet of the normal in the x1 y1, so which is a point on the ellipse. So when you take the locus of all these points, we will get the equation of a rectangular hyperbola. So that is the proof for